It turns out not all zombies are bad. Some just want to help remodel your tissues, heal your wounds, and then retire peacefully. Unfortunately, most of today's anti-aging strategies haven't gotten that memo. For the past decade, the war on senescent cells has been a biochemical purge. Find the cells that have stopped dividing, flagging danger signals, and nuke them with senolytics. But as research gets more sophisticated and more humbling, we're learning that senescent cells, much like people, come in many forms. Some are chronic troublemakers, true agents of decay. Others? They're just trying to keep things running during crisis. So the real question isn't just can we kill senescent cells? But should we kill all of them? Or, even better, can we just kill the bad ones and leave the good ones alone? That's where the new wave of senotherapies comes in. These aren't your grandfather's blunt force senolytics. These are smarter, sleeker, and far more diplomatic. The goal now is selectivity. Drugs that can distinguish between harmful chronic senescent cells that drive aging, fibrosis, and disease, and helpful acute senescent cells that are involved in wound healing, embryonic development, and structural tissue remodeling. We're moving from demolition to cellular architecture. If aging is a messy renovation project, these new drugs aim to knock down only the moldy walls, not the load-bearing ones. Here's the basic dilemma. Senescent cells are not a monolith. The bad ones, the long-lived, pro-inflammatory, DNA-damaged cells, produce a persistent senescence-associated secretory phenotype, SASP, basically a biochemical SOS that turns into chronic inflammation and tissue dysfunction. They hang around in joints, blood vessels, fat tissue, and the brain, contributing to everything from arthritis to Alzheimer's. But in other contexts, senescence is tightly regulated and short-lived. For example, during wound healing, senescent fibroblasts appear early, help recruit immune cells, and then disappear as the tissue regenerates. In fact, studies have shown that eliminating these helpful senescent cells too early can actually impair healing and lead to worse scarring. This is where it gets exciting because now we have the tools to tell these populations apart. Single-cell transcriptomics, proteomics, and AI-driven clustering techniques can sort senescent cells not just by which tissue they live in, but by what they're doing, what signals they're sending, and how dangerous they really are. It turns out that chronic senescence is often marked by a more chaotic SASP signature, higher DNA damage response activity, and different metabolic profiles compared to acute or transient senescence. These aren't subtle differences, they're molecular fingerprints. And if we can see those fingerprints, we can design drugs to respond accordingly. One of the most promising directions involves senolytic prodrugs, compounds that only become active in cells expressing certain stress markers or enzymes unique to harmful senescent populations. For example, some use SS-galactosidase activity, a classic senescence biomarker, to trigger drug release only inside target cells. Others leverage mitochondrial dysfunction, which is more pronounced in chronic senescence, to induce apoptosis. There's even talk of nanoparticle-based delivery systems that release their senolytic payloads only in fibrotic tissue environments, such as in aging lungs or fatty livers. It's kind of like giving your medication a PhD in cell recognition. But not every senotherapy needs to be a death sentence. A parallel strategy is emerging with xenomorphics, compounds that don't kill senescent cells but instead modulate their behavior. Think of it as re-educating zombies, calming down the inflammatory signaling, restoring some functional output, and convincing them to be less annoying neighbors. Xenomorphics like metformin and rapamycin, both famous for their geroscience potential, are being tested for their ability to blunt the SASP without triggering massive cell death. In some cases, turning down the volume may be better than pulling the plug. Another exciting angle? Timing. Acute senescence is often time-limited, like a pop-up construction crew. Get in, fix the damage, get out. If we can track the life cycle of senescent cells in real time, we may be able to deliver senotherapies at just the right moment, after the helpful senescent wave has passed, but before the harmful ones dig in for the long haul. This temporal strategy could revolutionize how we treat age-related conditions, especially those triggered by trauma, surgery, or localized inflammation. There's even speculation that in the future, we might train the immune system to do the cleanup for us. Some senescent cells linger not because they're invincible, but because they've figured out how to evade immune surveillance. By boosting natural killer, NK, cell activity or modifying T cells to recognize senescence markers, hello, CAR-T for aging. We might harness the body's own defenses to clear only the senescent cells that overstay their welcome. Of course, this raises some comic possibilities too. What if, years from now, we're not just taking vitamins for general wellness, but highly personalized senescence balancing capsules? One version for post-injury recovery, another for managing metabolic inflammation, a third to protect cognition. Are you on your monthly zombie modulator? Someone might ask at brunch. Yeah, mine targets IL-1S overexpression in my hippocampus. Really helps with memory and mood swings. So yes, the age of indiscriminate senolytic warfare is fading. What we're heading toward instead is a high-resolution, self-specific, context-aware approach to aging and chronic disease. We're no longer just trying to blast away the undead. We're trying to understand them, regulate them, and maybe even let some of them stick around, so long as they remember their manners and help keep the tissue in order. After all, some zombies just want to help patch a few wounds and go quietly back to sleep. The least we can do is not throw the cure at the ones holding the bandages.